Hi everyone, this is Jason Radford, the CEO for Volunteer Science. Today we're going to do our second installment of the fall workshop series on multi-person experiments. The goal of this workshop is to provide an overview of the field of multi-person experiments and to get you inspired and excited about coming up with different kinds of multi-person experiments. Drawing from many different traditions, there's a lot that we as social scientists can do to learn more about how uh, groups of people interact with one another and solve problems together. And so, what I want to be able to do today is sort of signpost a lot of the major traditions in the research, the major angles of the research, so that you have uh, an overview of what's possible for your research. Later on this fall, we're going to still have two more workshops. One in November on longitudinal studies. This will be a nuts and bolts kind of workshop on how to actually do those studies. So making sure that you collect people's contact information, get some empanelment data, and invite them back. So if you've never done a longitudinal study, or if you've done one or two, and we just want to get trained up on how to actually accomplish them, sign up for that workshop. The last workshop of the fall is going to be on incentivizing online volunteers. So how do you get people to do their best, either using financial incentives or not using financial incentives? As always, you can register for these at volunteerscience.com/events. And if you want to have a say in what we do this winter, the kind of trainings that we do, the workshops that we do, go to allarideas.org/vs_winter_2022 to vote on the current ideas or to submit your own for voting. And with that, let's get started. So today, I want to talk a little bit about the motivation for this. Where are we coming from as volunteer science? Where did this idea come from? And then I want to talk about the two major components of these multi-person experiments: the types of groups that people run and the types of activities that people do within these groups. Then I want to talk about some of the moderators and outcomes. So the many different kinds of tweaks and the many different kinds of things that we look at when we put groups and activities together. So first, let's talk about our motivation. This image here on the left is actually an engineering design diagram for a study done in 1952, I believe. So well before the age of ubiquitous computing and the internet. But here you have on the left-hand side these boards that are separating 5 participants. You don't see the people, but you see the boards. And in the middle, there's actually this mailbox system. And this mailbox system controls who can send notes to whom. So depending on this mailbox design, you can change whether player 1 can talk to player 2 or whether player 1 can talk to player 5. And using this, this miniature feat of engineering, researchers were able to do some preliminary experiments with groups on how the structure of communication affects how well groups solve problems. Now, fast forward to today. This is some research that we did while at Northeastern. We took this same exact paradigm of controlling who can talk to whom, and in this case, trying to solve a puzzle around when people are free to meet. So it's the same kind of problem that people were solving in 1953, trying to figure out how do groups share information until they find the solution. Same setup here. In this case, I'm user 3, and I can talk to user 1, user 2, and user 4, but I can't talk to user 5. And so we all have to share information until all of us come up with the answer, which is the one day that we all have freely available. Now, the advantage of modern day computing and the internet is, one, we have tons of control over the kinds of experiences people have, the kinds of communications they can, communication networks that we can create within groups, and the kinds of problems and activities that they can do. So there's just a lot more space for us to explore as researchers. Moreover, given ubiquitous computing and the internet, it's very easy to recruit groups very quickly and at scale. So using something like Mechanical Turk or Prolific or our ambassador program, you can run hundreds of groups over the course of a week or 2 weeks, or even less than that if you're really ambitious. And so over the course of the week, you can do more science than I think was published in the 1950s in small groups to research, just because of our ability to change the kinds of things that we're testing online, and the number of groups and size of groups we're able to run. So there's a lot of potential here for research on different aspects of multi-person dynamics. And that's what we're trying to get across today is what is that frontier? What's the potential for multi-person experiments? So just a little backdrop on where this particular framework comes from. So we did a review of the major traditions in multi-person experiments from psychology, economics, and other social sciences. Psychology has two major streams of research, one on IO psychology, where we're looking at teams and how do groups who are collaborating together accomplish shared goals. In social psychology, it's more looking at interpersonal influence and group influence. So how does one person influence a group, and how does a group influence one person? In economics, we have game theoretic traditions where, again, it's relatively small, one person versus another person, or two or three or four people together bargaining or coordinating, making some decision around whether to cooperate together or defect or how much money to put in. The other tradition in economics are markets. So people buying things, selling things, estimating prices for things, sharing information about what the value of goods is. Lastly, again, there's sort of a long tail here of traditions in political science, communications, network science. More recently, human-computer interaction, as we try to understand how people work together through computers. We've been creating new kinds of studies around multi-person interactions online. So a caveat here is that this typology is based on traditions and not breaking points in scientific results. So we think that there are natural breaking points in these results, but that's not where the typology comes from. Typology comes from reading the literature in psychology and economics and moving these the frameworks around until they fit into a nice typology where we can understand what makes one experiment different from another. Now, these boundaries aren't perfect. Many studies or many activities or many group structures have elements of other types. So there's no perfect delineation here, but I think these are useful. And when you look at individual studies, most studies are hybrids. So it'll be a study where it'll be sort of economics-like, but it'll look like, but it'll be interested in psychological outcomes, for example. And you'll see what I mean in a minute. But most individual studies involve multiple elements of the typology. All right, so let's talk about the first dimension, structure. So the structure of a group. This is the question of how will people interact with one another. As I mentioned earlier, in the case of the study from the 1950s, the structure there is a network. People are limited to who they can talk to. But most studies in psychology, IO psychology, everybody can talk to everybody else. This is the first structure, the sort of group, the normal group. Everybody can talk to everyone else. And I think the tradition here is very long, very robust, perhaps the deepest and most exhaustively searched area of research. But we're not done, I don't think. I still think that there's plenty for us to investigate here. And I'll show you what I mean later. So when we think about a group experiment, there are some basic essentials to the experimental framework. The first is you have to create the group structure. So in this case, on the left-hand side, there's an all-to-all communication chat box that we've created here for this example. On the right-hand side is the second element, the activity they're doing together. So when you're doing a group experiment, you're thinking about how do I get everybody to be able to talk to one another in a robust fashion? And then the second element is what is the problem that they're solving and how do I set it up so that they can solve it together? Are people typing in simultaneously and selecting their answers, or is one person sort of the leader of the group who's entering answers for everybody else? These are decisions that you just have to make as an experiment designer, but these come with the territory of doing group experiments. So here at the bottom, I've listed out what I define as the definition for group experiments. Participants interacting directly with everyone else to perform a shared activity. Examples, of course, groups and teams, but also if you're doing research with couples, or if you're doing research on juries and deliberation, you're also usually having participants collaborate with one another directly. Next, crowds. So this is this has become more of a famous way of looking at, or a commonly understood way of looking at this particular kind of structure more recently, with research on wisdom of the crowd and collective intelligence, though collective intelligence is separate from crowd intelligence. But a lot of the more recent research has used the frame crowd. But I actually will throw in most economic experiments into the crowd structure. And what I define as crowd is participants are acting independently, but their actions have interdependent effects. So, in an auction market, for example, player one is going to make an offer that says, "I'm going to buy 5 units at $1 per unit," and then they do that. There are 10 units left, so the player two has to buy 2 units at $3 per unit, and now there's 2 units left. No, sorry, 7 units left. I'm doing the math on the fly here. And so you don't see direct interaction between participants. Participants are taking the results of others' actions, or they're making their own actions based on the payoffs or potential actions of others. So again, what's really important here is that it's not directly interactive, but people are interdependent in their actions. So similar ones here, public goods. Good example of a hybrid here. There's a public goods network where we can change whose actions you can see. On the right-hand side, this is a crowd rating. This is a very famous study from Matt Salganik and Duncan Watts in 2008, where they had a crowd, look at songs, listen to songs, and then rate their quality. And they were trying to figure out, do early ratings determine later popularity of song or later ratings of songs. Again, you're not having people interact directly. They're just listening to songs. They see other people's ratings, or they see the aggregate rating, and then they give their rating. So that's what makes it a crowd. So examples, just to sort of lay it out here, these markets, dilemmas, bargaining, crowdsourcing, crowd tasking. I'll also mention swarms. A swarm is, you're acting interdependently, but you're not sort of exchanging actions. So with a swarm, I'm going left, and you're going right, and you go right because you see me going left. So we're sort of collaborating, but we're not directly interacting. And lastly, voting is another example here where, again, we're not directly interacting, but we're aggregating our behavior. When we're thinking about the essentials of the interface here, we're thinking about 3 things. One is the decision input. How do people make the decision? What decision are they actually going to be asked to make? In this case, for the auction market, it's the number of units that they want to purchase at how many dollars. The second thing is the decision rule. It has to be explained to people, what the decision has to be based on and what the implications of that decision are. In this case, I think however many units determines the number of the cost per unit. So if you bought 2 units, it would cost $4 for the first unit, and then $3 for that second unit. So you have to explain the decision. And lastly, you would think about the outcome and how do you show people the outcome. How many units did they spend, or how many units did they buy? How much money did they spend? How many units are left over? And what round are we in? So this sort of meta understanding of the game. So those are the 3 elements of a crowd experiment. The next structure, we have 4 structures in total. This is 3. Networks. I've already talked a bit about networks. The idea behind a network experiment is that you're controlling who can interact with whom. So player 1 interacts with player 2 and player 3, but they can't directly interact with 4 or 5. So in this case, again, the direction is that you have a subset of participants that people can interact with. On the left-hand side, we have this Babelis problem. This is the 53 study was done by Alex Babelis. And on the right-hand side, we have wildcat wells. In the wildcat wells study, you're drilling for oil in that sort of sandy space. On the left-hand side, I'm the top one there, so I see this 3rd round. I drill the yellow. This is fairly deep, but not very deep. I can't see player 2's wells, but I can see player 3. So I see player 3 hit a very low well, and I can't even see the little dot there. Sort of blends into the sand. But you get the example here of, I can only see or only get information from a certain subset of participants. So again, when you're thinking about designing a network experiment, you're doing 2 things. One, you're giving that shared activity, allowing them to make a decision, but you're also creating a system for network control. How do you make sure that people can only talk to the people that are in their network and not other people? So examples here, social exchange is a distinct tradition in sociology where you create a network and then the people in the network can exchange with their neighbors. And the idea is in round one, we're all going to make an offer to one or two or three or all of our neighbors. And then our neighbors have to make a decision about which ones they want to accept, and we have to make a decision around which ones we want to accept. And the structure of the network affects which exchanges get made. Network problem solving and network chat are similar examples. That's sort of up here. We have the network chat with Bavalist and the problem solving of Wildcat Wells. Lastly, institutions. Now, institutions is, I think, the least studied. You get it most in political science, and we have great experiments in political institutions. But there are a lot of social institutions where we can do more research on the kinds of behaviors that come out of them. So a couple of examples of how you do an institutional study. One is recruiting institutional members. So on the left-hand side, we have a couples and households lab. We want to have couples participate in studies together. You could also bring in police officers if you want to study officer decision making or policing. Bring in real jurists to study juridical decision making. The second example is more common, which is role playing. So having putting people in the position of pretending to be jurors, pretending to be voters. In this case, pretending to be detectives. This is a very thin version of the pretending to be an institutional member. Again, most studies are some degree of hybrid. But in this case, what you're trying to do as an experimentalist is understand how the specific institution acts, makes its decisions, sets a value, that kind of thing. So again, the definition here is that participants are trying to engage in a predefined and commonly understood form of social organization. If you want to have people try to participate in the institution of prison, you're probably not going to have people understand what prison life is really like. Same thing for on the street policing, for example. So you want to think about what is commonly understood and how does that relate to the external validity of your study. But in general, when we think of examples here, we want to say people who are simulating legislatures or running an election and sitting on juries. Same with financial trading and families. How do people make decisions in these relatively commonly understood situations? So as a summary, this is more of a reference slide. So take the screenshot, write this down, or come back to it. But again, there are four structures here. Dimension 2, activities. What do collectives actually do together? So this is, you have people together as a network or as a group, but what are they actually doing and what are the kinds of things they can do? So I'm going to borrow the McGrath circumplex, created in 1984 in IO psychology. This is a really helpful way of thinking about the different kinds of tasks that you can do. So there are two basic dimensions. These are arrows on the top and right. There's a cognitive and behavioral dimension. So how much of this is thinking and how much of it is doing. On the right-hand side is collaboration and conflict resolution. So how much of this is working together and how much of this is managing conflict or competing. And we're going to go quadrant by quadrant. The top quadrant, generate, and then choose on the left, down to negotiate, and then execute. So let's get into it. Again, very helpful. All right, so generative tasks. The question here is how much can we create and how well? So on the ideational side, this is generating ideas. On the planning task side, this is generating behavioral sequences. Again, planning tasks. Ideational, the sort of common one here, the traditional version of this is brainstorming, specifically uses for a brick. You have groups just list out as many ideas for uses for a brick as they can. Other variations on this are words that start with a certain set of letters like SHI, or words that start with A and end in Z. The idea for brainstorming here is you give somebody a prompt that they can't really prepare for, but they can do really easily. and have them as a group list out as many ideas as possible. And then you as a researcher come back and say, how many ideas were there? You do some data cleaning around repetitive ideas or topic classifications of many different topics of ideas that they come up with. The next sort of ideational task, definitions. So typically this is done as a funny or humorous thing. So definitions for a professor, with the example being someone who talks for an hour. That's a definition of a professor. And then the idea is how many funny definitions of professor can the group come up with. Related to this is metaphors and similes. So you give people, how many similes can you come up with for a rose? So a rose is like da 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 da, or metaphors for a road trip. And when you're on a road trip, you feel a road trip is a journey. Or a road trip is I don't know. This is a bad example for me. I would not do well on this task. But you get the idea. The groups are going to come up with lists of responses for this, and then your goal as a researcher is to figure out who comes up with all of the ideas, how many ideas do they come up with, what affects the number of ideas, what affects the range of ideas, lots of things to study here. On the planning side, you really want to nail down the things that are behaviorally true or behaviorally real, behaviorally realistic. Get people to not just come up with ideas that are off the wall, but ideas that have a real action component. So the first one is task planning. So coming up with the steps you need to buy a car, or steps for tying your shoe. So as a group, they need to come up with the steps and then organize them into an order. Collective planning. So this is a shared shopping task where person A needs to go to the grocery store and to the gym, and person B needs to go to the gym, but they also need to go to the park, and then person C needs to go to the park, and they also need to go to the grocery store. And then you have to figure out which do you go to first, and which do you go to second, which do you go to third, and you get points for how many people are satisfied by each stop. If you think about collective planning as a task. Next, choice. How do people make decisions? And this can be decisions about what's right or wrong, things that are more or less true, or it can be decisions as an aggregation of opinion or ideas. So on the intellective side, this is the right or wrong side. We have people solving these matrix puzzles, the Raven's matrices problems. For those of you who are not familiar with Raven's matrices, these are these shapes where you have 4 or 5 or 6 or 7 or 8 shapes, and you have to pick the 9th shape based on the previous 8. So it's usually shifting them around in your head or trying to infer the rules that are generating the shapes. Another example is Sudoku. There's a real solution to the Sudoku puzzle, and you have to find it. They have to find it. The other version of this is likelihood estimation. So you don't have to find the one right answer, but you have to find a really good answer. And how close do you get to a really good answer? So an example here is the multi-arm bandit, which comes from the economics tradition, where in the original version you have a bunch of slot machines, and you need to hit the slot machines until you learn which one is the most likely to give you the highest payoff. And so you hit the slot machine over and over again until you find the one that you think is going to pay off a lot. Same thing with Wildcat Wells and Traveling Salesperson. It's very difficult to find the one perfect path, especially in a large traveling salesperson problem. But you want to see how close you can get, or how optimized you can get. Was the highest possible value. On the decision-making side, again, there's no right answer on the decision-making side. People just have to come to a consensus. So one will be the elections and auctions. These are how people, again, aggregate their opinion. Who are they going to vote for? Who do they choose? Again, there's no right answer here. It's just who are they choosing. Value estimation. So this is something that's become more common and more interesting in the past decade or so, with forecasting competitions and getting better at estimation. So there's these forecasting examples. There's also estimating the number of beans in a jar, the wisdom of the crowd example. Again, with beans in a jar, it is close to a likelihood estimation. But at the time that with the forecasting a price in 1 month, at the time that you make that forecast, there is no correct answer. So you're trying to get as close to the correct as you can, but there's no correct answer. And lastly, collective rating. So evaluating the quality of art or evaluating the quality of something that has no intrinsic value. This goes. The example here is that's how Gannigan and Watts rating the quality of music. Next, negotiation. So this is getting into the conflict side. In this case, you are having to, or you're studying groups who are managing conflict on the idea side. So they have differing ideas about what to do or what's true. And on the other side, you have conflicting motives. People have different rewards or different incentives for different actions. So I'm going to start actually on the right-hand side with conflicting motives. This is a little bit clearer. On the bargaining side of the dictators and prisoners dilemma game, I have my incentives, my payoffs, the things that I can do, and the things that I do are going to impact your payoff as well, and the things that you do are going to impact my material payoff. And so I'm going to make my decision based on what I think you're going to do, and then we iteratively go through that until we reach the end of the round or reach some kind of equilibrium. Same thing with social dilemmas, these commons problems or public goods games where we're trying to figure out how much of a resource to share or how much to put into a common pot. Again, the more that I put into the pot, in the case of the public goods, the less, or the more we make as a group, the less I make as an individual. So there's a conflicting motive there. The last example would be elections with material payoffs. So I want party A to win, and I'm going to get a 5-point payoff or a 50-cent payout or a $10 payout. If party A wins, and you'll get the same sort of payoff if party B wins, and then we have to figure out who actually gets elected and how do groups pursue that election. On the idea side, there's no material reward here, but there is some idea conflict, and there is some sort of semblance or situation in which people win by having their idea chosen. I think the best example here is the hidden profile. It's sort of an unequal information version of this, where the information that player 1 is given is different from the information that player 2 is given. These pieces of information can be in conflict. So my information says, it's going to be, to go back to the example of the simulated detectives experiment. I hear that it's going to be, here we'll use the game of Clue. I hear it's going to be Colonel Mustard in the parlor. It's the one who commits the crime. But you hear it's going to be Colonel Mustard in the library. And we have to figure out, which do we want to say? Do we want to say it's going to be Colonel Mustard in the library or Colonel Mustard in the dining room? If they're non-conflicting, you would say something like, I think it's going to be Colonel Mustard, and you hear it's going to be in the dining room. And we have to come together and say, okay, is it going to be Colonel Mustard in the dining room, or is it one of us wrong? So again, when you think about conflicting ideas, one of the best ways of creating that is by providing people with unequal information. Other examples here are exploration, where with Wildcat Wells and Multi-Iron Bandit, you're trying to explore space, and you're trying to figure out where in this map is the most oil, or which of these machines are going to give the best payout. And I need to do my exploration to find what I think is right. You got to do your exploration to find out which one's right. And we can coordinate that, or we can come into conflict on how we want to explore that space and which one we think is the highest value. The last one is elections based on non-material payoffs. So again, we're not motivated by, the conflict is not based on our motives, but based on our idea. So I think that the red team is better. I think the blue team is better. Or I think that these sets of policies are better. You think those sets of policies are better. And how do we handle those elections? The last type of task or activity that you can do in a multi-person experiment is an execution task. So this is a question of how much do people do and whether they can do it better than others. And I'm actually going to start again on the right-hand side with task performance, and then I'll move back to contests. So task performance typically is pretty boring. But the thing is that, so I'll start with the example here, this transcription task. How much of a text can a group transcribe, or can a network transcribe, or can an institution transcribe? You give somebody some 2,000, 3,000 word text. It can be like a little short story. and the team then has to transcribe that text. Same thing with numbers. You get a long list of numbers, and the team has to transcribe the numbers. Now, what happens with task performance, what's important about these kinds of tasks, activities, is that one, anybody has to be able to do it. You don't want to have too much sort of pre-prepped expertise going in. I mean, you can do that, but then you're studying expertise, not necessarily generic task performance. That's why things like sorting is also a good example. Sort words alphabetically or sort numbers numerically. But again, the task has to be accessible to most anybody and pretty immediate, just to make it fair across groups. The last one, I'll give an example that's less boring, is division of labor, like a supply chain experiment. There's an experiment called the beer game, which now that we have issues in the supply chain in the world, I think maybe more intuitive than it used to be. But in a supply chain game, player one is controlling the sourcing of the material, player two packages the material, player three delivers it to the customer, for example. And so player one, two, and three have to work together to send as much of whatever, in the beer game here, they have to send as much beer as they can to the customers. And so as a group, you have to sort of maximize your execution there. On the left-hand side, the contest. You're doing the execution, but you're doing it either in competition or in conflict with other teams or with yourself. In a competition, you're not directly competing. So you're trying to do more text than another team. Or you're trying to do the text faster than the other team. This is the race. In a conflict, you're actually trying to stop the other team, or the other team is trying to stop or slow you down. So capture the flag is a conflict-based contest. Most sports fall into this example. Tic-tac-toe is another. Tic-tac-toe, chess, most board games are examples of conflicts. The game Risk, for example. In these contests, you're trying to understand how groups perform a task when they're being when there's an adversary, or how do they come up with adversarial strategies, for example. All right, so again, this one's for your reference. There are four quadrants, right, of activities: the generative, choice, negotiation, execution. The reason I like to pull these out is because they provide us with a big map of the space for multi-person experiments. So you have group experiments, and you can test how groups generate, how groups make choices, how groups negotiate, how groups execute. And what we see, I think, is that most disciplines fall within a certain subset of these experiments. So psychology, again, I think the space for groups has been really well explored from the perspective of psychology. There's actually, I think, a great place for us to do some more research, blending the disciplinary perspective in group research, and bringing in some of the network scientists, the economists into the group experiment setting. But I think going out, there's a ton of space that really just has not been explored. So this crowd work, I think a lot of economists have studied how crowds make choices and crowds negotiate, but there's not a lot of research on how crowds execute or how crowds generate ideas. There's been some, but it's just not that well established. Network science has really covered the network side, as you would imagine. Sociology is also here on the network column, so I don't have it here because it's not quite as well defined as the network science piece. And then political science has done the most to understand institutional choice and negotiation, but not necessarily generation and execution. So all this is to say is, I think there are a lot of gaps here, both in terms of just underexplored areas, but also sort of disciplinary owned spaces that we can be more interdisciplinary about. On top of this, there's actually a lot of ways that we can study each of these little cells here. So a group that's generative can vary based on the inputs. So the demographic composition of the group, or the aptitude of the individuals in that group. The processes that they use to generate ideas can be path dependent. So some of the early ideas for coming up with the types of bricks or the uses of a brick may limit future ideas, or some early sort of diversity of ideas may lead to a diversity of the results at the end. So you get bigger or more ideas. So you get study path dependency in groups. Same thing with strategy or effort at the individual level. And again, if we're looking at, just thinking about groups being generative, we can look at different kinds of outcomes. Equilibria, so are groups, saturating their ideas? Do they eventually, you know, generally max out at 100 ideas or 20 ideas? What's the, where are people ending up at usually? Um, how do people optimize or sub-optimize? What happens when people get to 500? How did that happen? Or if a team only comes up with 10, what happens to that? And efficiency, how do you make sure that for the energy that's being put in, how much work people are doing, how much do they get out, how many ideas do they get out? Again, at the individual level, how satisfied are people, how performant is an individual, what kinds of groups, what kind of group processes make for an individual who's really highly performing. And lastly, I mentioned status as a sociologist. It's an input, it's a process, and it's an outcome. So if you have somebody who's high status in a group, does that affect the group process, the group performance? In the process, people can gain status as somebody who's really creative, who comes up with lots of ideas. And as an outcome, people walk away and they say, that guy was really, really, creative, or she was really innovative in her ideas. So you can see that in this case, the kinds of inputs, outcomes, the moderators and mediators that we want to study here can be at any point in the causal chain. Lastly, I just want to mention a little bit about using artificial intelligence in multi-person experiments because it's becoming a really common area of interest. If we're doing research, people want to know how do you use AI to help groups make decisions, or how are existing teams going to work with artificial intelligence. So there are three different ways of approaching this. One is, and these sort of are progressive. So one is you simulate a bot. You don't create an artificially intelligent system. You just pretend to have one. So as an example, you can have like a prisoner's dilemma where you have a group of 10 people. Let's do public goods. It's a public goods game where you have 10 people and they're all putting money into the central pot. And the 10th person is a quote unquote bot. And that bot is going to do only one thing, and that's cooperate. And you want to know if it's a robot who's cooperating all the time, does that change behavior more than if it's a person named John or a person named DeAndre? Right, this is very traditional multi-person experiment kind of manipulation here. But the idea is that you just want to see, does the idea that it's a bot doing this behavior change people's perception of the bot or perception of the activity? Does it actually change their behavior versus when you label it as a human being? The next thing that you can do is use pre-trained bots. So this is where you train some model on existing data and then deploy it in a study and have people interact with it. So the most common example here are performance aids. So a lot of people have done research on messaging systems and what makes high-performing teams work well in messaging systems. And so you take your pre-learned model, you open up your volunteer science chat system, and then you have that chat system do things like recommend that people talk to one another. Don't forget to talk to player 4, for example. Or you should be more verbose, or you should use less direct or more direct language, whatever the bot is trained to say. And what you're doing there is you're seeing, does that bot actually work, and does this class of intervention work? Another sort of example that I won't go into is these conversational bots. Talking to bots, how do people like it? What do they do? How does it change people's behavior? And a creative bot, having bots come up with new ideas is no longer a new idea. The last example here, the last thing that you can do with artificial intelligence is training the bot with a group. So it can be pre-trained and then trained more with the group, or it can be de novo trained within an experiment. But the idea here is that you have a model that is learning based on the group within the experiment itself. And just for those of you who are really interested in this, the way that you do this would be using, at least for volunteer science, is using TensorFlow.js. So it's just a JS package, so it loads directly into volunteer science experiments. And you can load your pre-trained model into volunteer science and deploy it on people's browsers. Very straightforward. Okay, so if you're interested in learning more, you want to do an experiment, or you want to learn about how to actually design the thing, we have some material for you. So we've had a couple other workshops. The first, designing multi-person studies, here on our YouTube channel, was a workshop that we ran that's more of a nuts and bolts. How do you actually go about um, creating the interface, thinking about the order of having people log in, fill out the demographic information, da 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 da. It's a real nuts and bolts kind of workshop. We also have a workshop on recruiting subjects. So it's very general. It's not necessarily targeted at multi-person studies, but there is a section for multi-person studies there. And if you're thinking about recruiting or doing a multi-person study, I will go ahead and tell you the hardest thing is recruiting subjects. So definitely take a look at that. These are all on our YouTube page, as I said. If you're interested in getting your hands dirty and trying to figure out what kind of multi-person study you want to do, we have studies that are on each of these dimensions. So we have choice studies that are, we have Sudoku, word scramble, matrix reasoning, and hidden profile to give you a choice framework. Generate tasks, we have a brainstorming study template that actually can be used for all of the tasks. The brainstorming, the metaphors, the definitions. We have an execution task, the transcription task, so having people transcribe this long text. And lastly, we have a bunch of negotiation tasks, again, because most of the economics tradition is in negotiation and choice. We have tons of economics experiments and group problem solving experiments. So tic-tac-toe, Wildcat Wells, Prisoner's Dilemma Commons, Dictator Games, we have even more than that. But if you're really interested in working with different kinds of tasks and thinking about how to do a study on a particular kind of task, we have a template that you can use to really get started. Lastly, if you want to think about the kinds of structures that you want to create within your experiment, it's relatively straightforward to do an institution that you recruit people or you give people the right instructions to let them know that they're a jury. The difficult thing is actually controlling who talks to who. So in this case, we have an all-to-all chat. So if you want to do a group chat, you can do that. We also have a network chat where you can just put in your network and say, A can talk to B, B can talk to C, C can talk to D. That's all you have to do. And in both of these cases, it just takes about 5 minutes to use that template, set it up for your particular study, and you're done. And you can see those templates on our website, volunteerscience.com/experiments/templates. All right, thank you so much. Again, just a final reminder that we have 2 workshops left this fall on longitudinal studies and incentivizing volunteers. If you need help or you're interested in seeing these templates or want to learn more, contact me at jason_radford@volunteerscience.com. And again, vote for the ideas that you want to see us cover in the winter, or if you have an idea for what you'd like us to cover in the winter, add it to our allOurIdeas.org poll, our wiki poll. All right, thank you so much.